Greetings and welcome to the video on interrelationships between measurement scales. So let me get this on the board for us. Interrelationships between measurement scales. Measurement scales. Okay, that's going to be our topic in this short video. If you haven't already watched the video on just measurement scales and explaining them in a little bit more detail, I would suggest that you watch that video first prior to kind of coming back to this particular video. So really the importance of this video is I just want to kind of add a little more detail about how these kind of levels of measurement relate to each other. So I'm going to start here at the bottom and just kind of work our way up and build this together. If you remember, again from the other video, nominal is kind of our base. I'm putting it down here at the bottom. It's our most basic form of measurement. And again, here you're assigning numbers to different categories. So the numbers don't represent a quantity or degree. Remember, at this level we don't have any of the properties, no magnitude, no equal interval, no absolute zero, but examples here. So I want to kind of give some more pertinent examples, specific examples maybe even than what we did in the other video just on measurement scales when we were explaining mostly the properties. So an example here, again, I used this one last time, biological sex would be an example where you could have males or females, where males equal 1, females equal 2, males equal 0, females equal 1. Could be that, you wanted to use just an arbitrary number, males equal 17 and females equal 99. It doesn't matter, that number just represents that particular category. So what are some other examples here? You could, if you're using biological sex, you could have ethnicity, where it could be Caucasian, African American, Asian American, and you could just assign a number to that particular category. Another popular one that we do this with is political party, where you could have 1 equals a Democrat, 2 equals a Republican, 3 an independent, or something along this line. You do it with personality. You can do it with a lot of different things, but I think you get kind of the intuition there. So if we're going to build the next one in, the next one is our ordinal scale. Kind of building these as blocks, kind of in an ascending order here. And we know now that we have magnitude in terms of our properties, but no equal interval and no absolute zero, where here the numbers are again representing the rank order of the particular variable that you're measuring. The best example here is you're running a 100-meter race and somebody gets first place, they get second place, and somebody else gets third place. Well, it has magnitude in that first place had the lowest time, second place had the next fastest or lowest time, and the third place had the third fastest, the third lowest time. That makes a lot of sense to us. But when it says it doesn't have equal intervals, then what we're saying is the time difference between first and second place is not necessarily the same interval of time between second place and third place. Those are not equal intervals in terms of time. In other words, it could be a half of a second separating first and second, and maybe 3 seconds separating second and third. Therefore, it doesn't have the property of equal interval, but it still has magnitude to it. So then we build this up from here. Our next one was the interval level. And interval level meant that it had equal differences between the numbers, were essentially representing equal distances or differences in the variable or the attribute being measured. So for instance, let's talk about the variable, age, and the amount of time or age or distance between 2 years old and 3 years old is the same amount of time or distance between, say, 9 years old and 10 years old. So now 3 is greater than 2, 10 is greater than 9, so we have magnitude, that property of magnitude, and now we're meeting this property of equal interval or equal distance, that you could say the amount of age that has occurred between a 9 and a 10-year-old is the same amount of age that has occurred in a 2 or 3-year-old, but we can't express these differences as ratios or percentages because we don't have that absolute 0, which brings us to our final measurement scale again, which is ratio. And if you remember again, ratio is that we have the numbers now on our measurement scale are with reference to a true 0, which means an absence of that particular property or variable. And the scores can now be compared as ratios or percentages. Oh, by the way, down here, age can be, probably shouldn't have used that example, but age does have an absolute 0 to it. I probably should have used just years in general, like 1990 to 1991 is the same amount of time between 1992 and 1993. But let's use money up here. So let's talk about money, and we could say again the amount of money between $2 and $4 is the same amount of money between let's just say $15 and $17. We could also say that having $10 is twice the amount of $5. So we can express this as a ratio here in this particular example, because having $0 is in fact the absence of the property of money. You have no money. Okay, so this kind of just rehashes what we already kind of know about measurement scales, keeping in mind that age would have actually been a ratio. I should have used years here. And what I want to talk about is just real quickly the kind of the relationship. It's often not always straightforward when we're going to talk about a variable, which one of these scales it's going to be on, and hopefully these examples are helpful in giving you a sense of intuition. But I guess really what I also want to hit is that as the researcher, you can oftentimes take a variable that's at a higher level here, let's say that's something that's a ratio, and you can move it down. You can move it down to either an ordinal level, or you could even move it down to a nominal level. So for example, and you've probably seen this on surveys before, you might see something that says, just a question that says, what is your annual, family income? And it might just be a question mark and an open kind of blank line here, and you're going to collect that as some kind of real set of numbers or integers, and that would kind of meet this interval scale here piece. But another way of kind of asking this same question would be, what is your annual family income? And then have a 1 equal the category of, say, we're just going to say, you know, $20,000 to, you know, $29,999, something like this. A 2 would equal, you know, 30K to 39,999, and so on and so forth. How many ever categories you wanted, and then somebody would just, say, okay, my family income is this one right here, and I circle it. And so oftentimes the researcher can kind of manipulate and or kind of deregulate, if you will, the ratio or interval type of variable into something that's either ordinal or nominal. So I just want to keep that in mind as you kind of move forward, and this will kind of then help us segue into talking about the concept of variable types.